Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Apa kabar semua? Sehat?
Alhamdulillah, no comment.
Penat, bunyi penat ya. Pagi-pagi kita penat. Ya, apa macam ni? Macam mana puasa ni? Pagi dah macam penat dah. So, how's Ramadan? Everything fine? Okay, alright. Today I have a few announcements. Actually, I have only two announcements. Number one is about our makeup class. I think I will do that after the break, after the Hari Raya break, because I missed Sunday. The other one is about our test. So we have the test before the break. Okay, our midterm, I will have it before the break, because if we do it after the break, most of the things we will forget, right? Because I don't think we are going to do anything. So let's finish the thing, before the break, and then you go have fun during the break. So we'll have the test after the break. Now, question is, do you want it this weekend or next weekend? The test. You want this weekend or next weekend? We are going to do it on Sunday. Okay, that's the only available time for everybody. And I wanted to do it together with the other sections as well.
This weekend.
This weekend?
Next weekend.
Next weekend, sir. Next weekend, sir.
Next weekend.
Next weekend, sir.
So majority kata next weekend, so next weekend lah. All right, we go by the majority. So the midterm, all right, would be on next weekend. Next weekend, Sunday, okay? Because that's the day that we want to make. I want to make up the makeup class, but and also the only day everyone is available. So the date for next weekend is on the 9th of May. Okay, that is on the Sunday. And we're going in the morning. Okay, most probably 10 a.m. This is okay. One. Now the coverage. The coverage would cover everything from the first topic, okay, that is on the linear function, up to the one that we're doing now, partial derivative. Okay, so we'll be up to partial derivative. If we do another topic before the test on another subject, another topic, that will not be covered in the test. Okay, that's about the test. Now, second is, like I said earlier, I will have the makeup class will be I will set that. Okay, we'll set it after the break. All right. The break, this semester the break is very, very late. You have actually the break during the week number 10. So, week 10, and then after the break, we have another 4 more weeks left. So, I hope we can cover at least, integration, some part of integration before the break. And then only we can do the last topic during that 1 month. Okay, now, any question, any comment, anything? Okay, so if there is nothing, we will continue. Now, what I want to do today we'll go into application. Okay, application of the partial derivative. This is on 14.3. 14.3. So 14.3, we are going to look at applications of first partial, and then we are going to go to 14.4. We are going to do the maximum minimum test. Okay, maximum minimum. And then I hope we can do that today. Now, application for this part, we go to 14.4. Look at 14.3. Look at example number 1. Okay, this application is on the first partial. Okay, that means first partial derivative. In other words, we are going just to look at if you have the function z equal to f of xy, then we are going to look at the first partial, namely zx equal to fx equal to df dx or dz dx. So when you look at this notation, you can see the change. Okay, you can see the change. If there is a small change in x, then what is the change in z? And that change in z is given by delta z. So, in other words, we are going back to the basic interpretation or basic description. We go back again to delta z, delta x. So the idea will be like that. Okay. So you have a small change. A small change in x, then the delta z, okay, the change in the z will be given by what? Will be given by the value of the slope. Okay, the value of the slope will be given by fx, the value of the slope fx at a particular point. Okay, and here you assume what? Given y constant. So that's how we think of the application, and how you describe the partial derivative. So the way we describe it, in other words, just slope at a point. All right, slope at a point. The slope at a point with respect to the independent variable. So slope at a point with respect to a particular, with respect to independent variable. Okay. So if you look at the other partial derivative, I got zy, that is fy. Think of it as dz dy. And how you describe it? We go back to the change, delta x, delta z over delta y. So there is a small change in y, then delta z is given by the value of fy. All right? So the fy, the slope. So again here, we're talking about the slope at a point with respect to y. Here, the slope at a point with respect to x. Right? And of course, here, slope at a point with respect to y. Okay. All right. So that's the idea when we want to describe the partial derivative. So let's look at example number 1. You have here a cost, okay? Cost of producing 2 products. So in a company or a firm, here you sell, or no, you sell, cost you produce. Then you produce more than 1 product. We can produce 3 or 4 or 2. So here we are going to look at what? 2 products, which are common, okay? Common practice. For example, you can produce 2 products. Okay, what are common? If you look at some firm, if they produce more than one product, what are they? You give me one company, real company, and then name their product.
Nestle.
You look at a big company, that's a very big company. So Nestle, okay, Nestle. What are the goods they produce?
Chocolate.
Okay. So you see here, many things they produce. For example, chocolate. Chocolate, apa banyak jenis? Okay, what else? Okay, we generalize chocolate as chocolate. Okay, what is the other product?
Hot drinks.
Hot drinks.
Hot
Okay.
drinks.
Chocolate. These are chocolate bars. All right. And here you got the drinks. The drink mix, like Milo, apa lagi dia buat? Nescafe. Okay. So these are drinks. So you produce more than 2 products. In fact, this company produce, I don't know, hundreds of products. So you look at these companies, they produce more than 2 products. So for example, you have here the cost given by the equation. You have the cost equal to, there are 2 goods, X and Y. So let's say, the X and Y is the chocolate in bar, 1 bar of chocolate, like that, 1 bar. And then the drink, this is the powder, what do you call that drink? Macam Milo, kita panggil benda. Drink powder.
Instant drink.
Instant drink, okay? Instant drink we call it in
Sachet.
Apa?
Sachet.
Apa benda?
The packaging, sir.
The packet. Kita panggil packet. Okay, packet. So units is in packet. That's the Y. And the other product, chocolate bars, X in bars. Okay, in the number of bars. So here you have these 2 products and the cost is given by the function. So now what you want to do here, you want to find the marginal cost with respect to X and Y. All right. Now, what is marginal cost? How do you get marginal cost? So you go back to what you have learned. What is marginal cost? If you're, from the derivative of one independent variable, if you're talking about cost function, then how do you get the marginal cost?
Differentiate the cost function.
The derivative, okay? So here, you want to have the marginal cost with respect to X. You call it MCX. So that is the marginal cost with respect to X. That is the derivative of the cost function with respect to what? With respect to X, which is chocolate bar. And that is equal to CX or dCdx. All right? And then you want to find the marginal cost with respect to Y because there are 2 independent variables. So MCY is the marginal cost with respect to Y, and that is notation CY or delta C, delta Y. Okay, so the marginals are the derivative. So in this case here are the first partial derivatives. So if I want to find the marginal cost with respect to X, then what do? You take derivative with respect to X. So MCX, all right, equal to CX, that is the notation, or you can use delta C over delta X. Then take the derivative of the function with respect to X. So what do we get? So Y is a constant, okay? Y is a constant and the function is fairly simple. So what is the derivative? You get what? You got 2x plus And there is another term, 8xy, so 8y. Okay, and then I want to find the MCY, that is the marginal cost with respect to y, or I can write dc dy. What is it? So now you differentiate with respect to y, the x is a constant. So I got 8x plus 3y squared. Is that right? Okay. So those are the first partial derivative. And in terms of the application, they are called marginal cost with respect to x and marginal cost with respect to y. Okay, now the next part is you want to evaluate, all right? You want to evaluate the marginal cost at a certain output level or at a certain point. So the second part, you want to find, okay, you want to find the marginal cost at a certain level. So let's say you want to find the marginal cost with respect to x at what? At the point 5.3. So in other words, if we produce 5 bars of chocolate, 3 packets of drinks, what is the marginal cost of producing, or what is the marginal cost with respect to x? That means with respect to the chocolate bars. Okay, so in other words, if we increase production of the chocolate bar, then what is the increase in the cost? Okay, so what you do here is we substitute, okay, 5.3 into what? Into the marginal cost with respect to x. So what do we get? You get 2 times 5. So what you have will be MC x is equal to 2 times 5 plus 8 times 3. So that will be equal to 34. So here, if we produce one more unit, all right, one more unit of the chocolate bar, in other words, if I produce one more bar of chocolate, then what happened to the cost?
Cost increased by 34 ringgit.
The cost will increase by that amount. Okay, so that marginal cost, the value would be the increase in the cost. Okay, with respect to that particular independent variable. So how do you describe it? Right? How do you describe it? Firstly, you have to mention the point of the derivative. That means at that point, because you know this is non-linear function. At a different point, you will have a different slope. So you say that at 5.3, or you can say currently producing 5 bars of chocolate, 3 packets of drinks. Okay, then if we produce one more unit of the chocolate bar, then what happened to the cost? All right. So if we produce, or if the company lah, not we lah. So here we means the company, the firm. If the firm produces one more, okay, one more bar of chocolate, then what happened to the cost? Cost will increase by $34. Okay. Now that is not the full. That is not the complete interpretation. What else do we need to say? I already say the point of the derivative, and then we already look at the meaning of the first partial. All right. Now, what else do we need to say? Do you remember? You know, when we are talking about partial derivative, what is the other condition that we set before, before you describe the slope?
Y is constant.
You keep y constant. Okay, so you keep y constant here, meaning I keep the other product. Okay, the other product, I keep the drinks constant. At what? At 3 packets. Because you have 5, 3. Okay, 5 is x. So here you know xy. So the one that we increase production by 1 unit is x. That means I produce one more from 5. That I got the 6. I produced the unit number 6. But for the other variable, okay, the drink, you keep constant. So where do you keep constant? At 3 packets. So the one that only change is x, which is what? Which is the chocolate bar. All right. Okay. So now, any question? So you have to mention the point of the derivative. Okay, the point where you take the derivative. So in this case, partial derivative, huh? And then you describe the slope. Okay, with respect to that particular variable. And then you have to say that the other variable is kept constant. Okay, now I want you to describe the other one. Okay, so describe MCY. And again here, I think now we use the same point. Okay, 5, 3. Okay, all right, do that now. Interpret the marginal cost with respect to Y at that same point. Then I want you to give the interpretation. Okay, first, what is the value of the partial derivative? Muhammad Fahimi, what is the value of the partial derivative? MCY?
51.
Huh? 51. Okay. Everybody got 51? So you substitute into MCY, not MCX.
Bukan 67.
67.
67 kan? Okay, so you got the value 67. Now you put into the MCY, you put the value into the marginal cost with respect to Y. Because now we are going to find the marginal cost with respect to Y, MCY. Okay, all right, so you get how much? 67. So now how do you describe that thing? Cepatlah, anybody. Tak kisah siapa-apa.
At 5.3, if the firm produce one more packet of drink, the cost will increase by $67. Keep the chocolate bars constant at 5 bars.
Okay, so you have to describe, first of all, the point of the derivative at 5.3, or you can say the longer term, when currently producing 5 bars, so it's too long. So just say at 5.3, if the firm produce one more packet of drinks, the cost will increase by $67. We keep the chocolate bars constant at 5 bars. So you have to describe, all right? You have to describe the full meaning of the slope with respect to that particular variable. Okay, All right, so that is our first example. Now we move on. We look at example number 2. Okay, example number 2, we are talking about what? We are talking still again here, the cost. I think it's the cost. Okay, you go ahead, read that example 2. Okay, example number 2. Okay, read that. I give you 3 minutes because I also need to read. Z is the bushel of a crop that can be harvested by. Oh no, this one is not. It's not cost. Okay, it's not a cost. Because you're talking about harvesting where 100x hours of labor employed. Okay, and Y acres of land. What would be the output if 200 hours of labor is used and the amount of land is 300 acres? So here it's on production, all right, because you're harvesting the crop, so that is more on production. So we are talking about production of a crop, given, all right, given the inputs. Number 1, labor. Number 2, what? Number 2 is the land. All right. So you have here the crop. What is the crop? They don't know. We don't say what is the crop. So here, all right, the crop, which is the Z, right? The crop in bushel. So bushel is the unit. Okay. So you call this bushels of apa benda? Bagi nama. Give the name of the crop. No, crop can be very, very general. So give a name. Bushels of what?
Carrot.
Bushels
of.
Bushels of what?
Sorry, tak tengok pula bushel.
Selalu benda kita pakai bushel datang mana?
Corn.
Corn. Okay, corn or rice. So corn. So bushels of corn. And then you have bushels of the crop, corn. And then the X, the inputs, the labor. Okay. So you got here labor in what? In hours, working hours. So work hours of labor. So work hours of labor. Now, this is what? This is in hundreds. So the unit is 100, not in one unit. Okay, not in one work hour. It's not 1 hour. Okay, it's not 1 hour of labor. We are talking about what? We're talking about 100 work hour labor. Okay, so that means when you say 100 here, if the X is equal to 2, it's not 2 hours. It should be what? It should be 200 hours. Okay, because the unit is 100. If the units are in thousands, then what? The units are in 1,000 hours. So when X equal to 2, then how many hours actually it is?
2000.
2,000. Okay, you don't write 2,000, you write 2. But it means what? It means 2,000 because the unit is in thousands. So that is X. Now Y, another input will be land. Okay, land in acres. So you got these 3 variables clearly specified. Okay, and then you want to find what? You want to find the first partial derivative with respect to X and Y. Similar thing, So here, the only difference will be you need to find the derivative by using quotient rule. I think so. Yeah, quotient rule. So the function is quite not as simple as, I think it should be, but we have to do it. So this is a practice of finding it by making the, or is it already? Yeah, that effect and why progression is change in many parts of the thing called productivity. Yeah, they didn't find, okay, they didn't find what do you call it? They didn't find the marginal. They only give you the total. Yeah, you know what? That's the thing that I didn't mention. We only talk about the marginals. Go back to example number 1. We also need to mention or to look at the level of output. All right, the level of output where you produce at that particular point. So there is another thing that that we can do. Go back to the example number 1. I think I will put it there. Put it. Okay, go back to example number 1. So now what you can do, you can find, okay, at a certain point, say 5.3, you want to find what is the output that is produced. Oh no, in the first example, cost. So what is the cost of producing 5 bars of chocolate, 3 packet of drinks? So you want to find the cost. So again here, what you do, substitute 5.3 into what? Into the cost. Okay? Because you are not looking at the marginal, you are looking at the level. So we are looking at the cost. How much is the cost to produce a certain amount of X and Y? Okay, so we just substitute XY into the cost function. So the example of 5.3, you can put what? I can put here 500, 400. So if it is 500 bars of chocolate, 400 packets of drinks, then what is the cost? You substitute into the cost function. Okay? The marginal, the first partial is talking about the increase, the change. Okay? The cost is about the level, actually, what is the value of the function at that particular point. So for 400, 500, you find, okay, you find later, not now. Okay, so look at example number 2. So we're going to do the partial derivative. The book didn't do the partial derivative. So we do the partial derivative. You see there, at x equal to 2 and 300, I think we change the value. Let's say at x equal 200 labor hours, and the amount of land is 300 acres. So we change it at 200. So given 300 hours of labor and 200 acres of land, all right, you want to find the production or the harvest. So you put into what? You substitute into what? Substitute into, so you will get the value. So this one you do later. Okay, that is the level. Similar to that example. Now what we want to look at is the partial derivative. So the partial derivative with respect to x, what do you call it? The partial derivative with respect to x, that will be equal to z x dz dx. We call this, if this is a production, sometimes, for production, it's convenient to label it as Q. Okay, so Z is equal to Q. Q means the quantity. So the crop Z here, we can equate that to Q. That we can actually relate Q is the quantity. So then you can see the marginal productivity. So that will be dQ dx. So we can label the function, okay? Relabel the function instead of Z, we can use Q. So Q is equal to whatever the value is, no, whatever the function is, that will be what? That will be the partial derivative of Q with respect to X, and this is called the marginal. Again, here the word is marginal, but we are talking about marginal what? Marginal product. Okay, marginal product of labor. And sometimes they put marginal productivity. So you can also include TVT, but marginal product itu dah cukup lah. Okay, and then the other one will be ZY or DZ dy or DQ dy. That will be what? That will be the marginal product of land or marginal productivity of Y, which is land. Okay, all right. So now I want you to get the marginal productivity. I want you to find dQ dx, dQ dy. And that function is quotient rule. I think you do it at home. So I give you homework, all right? Because that thing, you know, need time. So homework, you find that thing. Okay, you find the marginal productivities and then interpret. So interpret, we already do. So you just apply the interpretation. So that will be homework question. Okay, all right. So that is example number 2. No, example number 2. Now I want you to look at another production example. That would be example number 3 and example number 4. So we go to example number 4. Okay. So I want you to read example number 4. So example number 4 is production. No, I want you to read for a few minutes. What is the X and what is the Y and what is the Z? Okay, got it. So that function, you know, we call it production function. Production function similar to example number 2. So here you have that form of function, we call it Z. And again, like I said, you know, we sometimes it's good to use Q. I prefer Q because Q is quantity. And then that is equal to some constant A multiplied by X to the power of alpha, Y to the power of beta. So A, alpha, beta, they are all constants. Actually, they are positive constants, all right? Positive. Okay. And here Q is the output, whatever the unit is. And then, oh yeah, no, before we do that, before we put the output or whatever, I would like to describe, you need to also mention This is output. Okay, X and Y are the input. Okay. So this kind of function, you call it Cobb-Douglas function. Now, this is a very popular function in economics. If you look at, if you have taken principles of micro, utility function in form of Cobb-Douglas, production function, Cobb-Douglas. So it's quite popular, it's quite widely used in economics. And the general form is this form. A constant multiplied by x to the power of some constant multiplied by y to the power of another constant. So we denote by A, alpha, beta. So example, all right, example, you get Z. I can put here Q because we're talking about production. Say equal to 25 x to the power of 0.6 y to the power of 2. So that is an example. All right. So that's what you call Cobb-Douglas function. So you look at example number 4. You have the function given there, and x is the inputs, y is the input. And normally, okay, the inputs that we use are labor and capital. So here, you look at the example number 4. What is the amount of labor? And then capital. So X is capital, correct? So here I put the units. Okay, I think we are going to use units other than the dollars. So here I use unit, right? We modify a little bit. And then Y is labor, also in units of labor. Now, units of capital means the physical unit, not in money value, okay? Physical unit. That means if the factory has 2 machines, all right, 2 machines, we don't talk about the money investment in the 2 machines. We're talking about 2 units of machine, all right? So here 2 units of machine. Okay. Similarly for labor, we're not talking about the labor hours. We're talking about what? How many labors are there? So unit means the number. Okay, the number. So number of workers, for example, labor, again here, physical unit. All right, so both are physical unit. For the labor, Y, example, we can say 5 workers. So the unit is the number of people. Okay, so we don't put the hours. So I'm going to yes, make that change. Okay, all right. So for example, you've got here Z equal to, or I use Q, Z equal to Q equal to 100 x to the power of 1 over 4 y to the power of 1 over 4. So what do you want to find first? I want to find the marginal productivity of X, which is the marginal productivity of capital. Okay, so how do you get the marginal productivity of capital? Or the marginal product of capital? How? Hello, hello, hello. Anybody here?
Derivative of Z with respect to X.
You take the derivative with respect to X because X is capital. Okay? So I want you to get the derivative. So number 1, A, all right, find the marginal product of capital. Okay, which is X, marginal product of capital, that is MP X. M marginal, P product. Okay, so marginal product of capital. sometimes, we put in economics, I don't put that, okay, X, or, oh yeah, we just, or MPX. So this X is not subscript of P, okay? The X is just a small x. So you take derivative with respect to X. So dq, d, or you can use dz dx. Okay? And then part B, I want you to find the marginal product of labor, MPY. So get it. Can you do the partial derivative? Okay, find both of them. I think they do it in there already. The book, they work it out. So you don't just write what the book gives. Okay, I want you to find it. After you do the computation, and then you can refer to the book to check whether we are right or we are not. So please do on your own, and then you can check the book to see whether we are correct. Okay, do the A first, and then we do it together, and then we move on to B. Okay, you got it? Okay, firstly, you just take derivative of the Q or the function with respect to X. X is capital. So what do you get? Now remember, okay, X and Y, they are multiplicative terms. So Y is a constant, but don't throw that Y away, okay? The Y will stay. So MPX is equal to what? Equal to, so now, like I said earlier, it's good that you write the function Q equal to 100. Okay, this is just for starters. Okay, if you are not so sure yet, you put the Y together with the constant. So Y to the power of 3/4. Now, that is our constant. All right, so don't worry about these two things. You just worry about derivative of the X to the power of 1/4. Okay, but if you already familiar, all right, you have already do a lot of practice, you understand, so you don't have to do this. Okay, you just put Y where it is, and then you got what? I got 1/4 multiplied to X. 1/4 minus 1, what do I get? 1/4 minus 1 minus berapa? Negative apa? Negative 3/4. Is that right? So that will be equal to 25 Y 3/4 X negative 3/4. So this is not QX. You know what? I think I expressed. So well, I told you, kita don't go express. Then we go step by step. Because if you express, sometimes you cut and paste. Okay? You don't do it by yourself. You just look at somebody's work. So you got 100 Y to the power of 3/4. Okay, X to the power of 1/4. So now you want to find the marginal product of X. So MPX equal to dq dx. Now you do the partial derivative. The 100 Y to the power of 3/4, that is a constant, so don't worry about that. We'll follow the derivative, multiply by 1/4, X to the power of negative 3/4. So what do we get? We get 25 Y to the power of 3/4, X to the power of negative 3/4. Okay, all right. Okay, you got it? Okay, if you got it wrong, okay, you check where your mistake is, so that you know where your mistake is, then you understand better. Okay, so it doesn't matter whether you get it wrong or you get it right. you got it wrong. Now you know where you got it wrong, and then that is the place where you want to make the correction. Okay, so that's why I want you to do it on your own. Don't just look at the book. The book that just give you the answer. Okay, we don't just want the answer. We want what? We want the process. Okay, so that's how you take the partial derivative. All right. Okay, so what you want to do next? If currently there are certain amount, so now we don't draw the graph. Okay, you don't draw the graph because to draw the graph is not that easy. So what I want you to do next is that I want you to find first. Oh no, this is the one that we already do, the MPX. Okay, now I want you to find MPY. Okay, so now we'll do it. MPY equal to dq dy equal to, okay, now, okay, this one you find. So if you're not sure of taking the derivative of the constant, okay, the variable that we keep constant, you do what I'm doing here. If you are sure already, then you don't have to, okay? You just take the derivative as per the original form. Okay, you got it? So here, the x is a constant, y is the variable, okay? So dq dy is equal to what? Is equal to, okay, now, I assume that everybody understand that already, but it's okay because the x is near the 100. So you got 100 x to the power of 1 over 4. So now, okay, we know the x is a constant, so now we don't have to put the bracket, okay, because we are familiar. And then you multiply by 3 over 4, and then y, 3 over 4 minus 1, what do I get? I get negative 1 over 4. So what is it equal to? 25 times 3, 75 again. So there will be 75 x to the power of 1 over 4, y to the power of negative 1 over 4. Okay, all right, good. So now you got the marginal productivities. We want to find, okay? We want to find, so C, let's say at X, Y, no, you don't have to write. Say 6 and 10, 6 and 20. In other words, if we are currently using 6 units of capital, 6 units of machine, and 20 workers, all right, I want you to find, number 1, the output level, okay? And then number 2, the MPX. And then number 3, MPY. Okay, so there are many people here. All right, for the Q, I want the people, your name from A to K. Okay, do Q, and then you share. And then MPX, because I need the time. A, B, C, D, K. Lepas K apa? K. A, B, C, K.
L, sir.
Hah? A je?
L.
L. Saya pun tak ingat. L to N. Okay. And then MPY, if your name N to Z, okay, you do MPY. Okay, do it quickly. And then, okay, and then I want you to describe how you get your answers, because so that the other people can understand how we get the value. Okay. Anybody get whatever you are supposed to compute? It doesn't matter whether MPY or MPX or Q. So whoever got the solution first, let me know. Okay, apa dia? Anybody? Susah sikit tu. Sebab apa? Because the function, the function is power, ada power tu. So what you do, okay, in order for you to compute the value, you bring the X, okay, for the MPX, you bring the X downstairs, okay, so that you will have a negative power. So you know what you can do, you bring it downstairs, so you got 25, y to the power of 3/4, x to the power of 3/4. And similarly for the MPY, okay, so I got 75, x to the power of 1/4 divided by y to the power of 1/4. Get the value. Okay, anybody get the answer? Cepat.
Yang Q satu, yang Q Q 1480.17.
So the Q, how do you get that Q?
Substitute into the
Substitute.
question.
So to get the Q, you substitute into Q. All right. So what do you get? 1,000?
1480.
1480. Okay. Anybody get different answer than 1480? If you get, very close, biasalah. But if you get another number, say 2,000, that is the big difference. Semua dapat 1480, Okay, so you substitute into the Q. All right? That is the level of output. So when currently we are producing, not producing, so when you are using now, okay, using 6 machines, okay, 6 machines, and then 20 workers, all right, how many units of output can we produce? 1480. Okay, all right, good. Now MPX, what is the value of the MPX at 620?
61.67.
Okay, so you got here MPX equal to 61.67.
67.
Okay, so you substitute 6y into MPX. Okay, which is this one, which is all right. Okay, MPY. Right, MPY.
55.51.
55.51.
51.
Anybody get different answer? Betul, okay, that's good. So you substitute into the MPY. All right. So there are 3 things here. One is the amount of output produced. Number 2, the marginal. Okay, the marginal. That means if for the MPX at 6 and 20, if I use 1 more unit of capital, all right, then what about output? How much output will increase? Output will increase by 61.67 units. Keeping what constant? Keeping labor constant at where? At 20 units or at 20 workers. Okay, so I hope you're right. Okay, by now I think you understand already. We just what is MPY? MPY means that is the marginal product of labor, because Y is labor. So in other words, at 6 and 20, if I use 1 more worker, or if we hire 1 more worker, then what about the output? Output will increase by how much? Output will increase by 55.51 units, keeping capital constant at 6 units. Okay, I want to write, but I cannot see all these numbers, so difficult. All right, so everybody write. Okay, I want everybody to write now. Right, what I say, because I know, I think we already have the concept. All right, we have the idea already. Okay, all right. So yeah. So the level tu, macam ni. The level is if the firm, okay, use 6 units of machines of okay, and 20 workers. Okay, then how many units can we produce? Then output produced is how much? Output produced is 1480 units. So that is the level, that is the amount. Now MPX, okay, MPX at 6 and 20. All right. Now, what is the output that we increase? X. X is what? X is the capital. If we use one more, okay, one more unit of capital, or we add another unit of machine, then what happened to the output? Output will increase by how much? Output increases by 61.67 units, keeping what constant? Keeping labor.
Keeping the size of labor.
Labor fixed at 20 units. Okay, so I want you to write the MPY lah. Okay, so that is the increase in the output when you increase one input, keeping the other constant. So now we can go one more step. You look at the marginal productivities, which marginal product is higher? Is the marginal product of capital higher or marginal product of labor higher? Wait, which one is bigger? MPX.
Capital.
MPX is higher, that's right. MPX is higher because MPX is 61.67. The MPY is 55.51. So if I hire one more capital, the increase in the output is larger. Okay, so which one is more productive? Which one, if I want to hire more, which one I should hire more, capital or labor?
Labor.
Apa saya labor pula?
Capital.
Capital lah. Because capital will increase output more. Is that right? If you hire labor, one more worker, the output increased by 55.51. If I hire one more unit of capital, the output increased by what? 61.67, which is more. So if I want to increase one output, one input, so I want to take what? I want to take the input that can increase output by larger amount. Okay, so you call here the one that increase output by larger amount, you call it the output is the input. I'm sorry, the input is more productive. So here, capital is more productive. In other words, if I want to hire one input, at that point, I will hire what? I will hire one more unit of capital because it increased output by larger amount. Okay, all right. So that is example number 4. Now, example number 5, that is on the demand function. Actually, example number 5 and number 6. All right, and you see the nature of the derivative. You see there you have competitive, and then you have complement. So that part, okay, that example, there are 2 pages. Example 5 to example number 6. In between, there is some explanation. So in my book, page 878 and 879, okay, I want you to read that part. Okay, so that is your reading assignment. I just want you to read example 5 and 6, and then what is the meaning, okay? The meaning of the competitive and then complementary, the types of the partial derivative. So example 5 and example 6, I want you to read. Okay, read, and then also understand what we mean by competitive and complementary. Okay, all right, good. So that's it. That is the application of partial derivative. So we are done with 6.3. I'm sorry, 14.3. I'll give you some homework question, practice. Okay, basically related to what we were discussing. Okay, for the cost function, 14.3, I would like you to do number 2 and number 4. And then the production, you try question 13. Two, 4. I think you need to do the interpretation as well. So I give you another one. All right. So do number 8. Okay, because number 8, they want you to interpret. So do number 8. And then for the production, that is on the marginal productivity. So I give you another question for you to interpret. Okay, we do number 22. 13, 14, 22. Okay, for question number 22, they ask you also to draw the graph. So don't draw the graph, Don't worry about the graph. So what you do for 22, I want you to do part A. All right. And then for B, I'm going to change the unit. All right. So labor force is 729 working labor hours. And then you get also, so for that question number 22, you start with, okay, we use the point here 620. So here we use X is the capital. So I use 10. 10 and 24. So X is 20, 10. So X is the capital. Okay, capital 10 units, workers 24. Okay, labor 24 workers. So we use this. Don't use the labor hours. Okay, use this point for question number 22. And then you don't have to draw the graph. Okay, you answer part A. And then I want you to find the MPX, find the MPY, C, interpret. Okay, interpret the B. All right, interpret B, and then compare. Compare the MPX dengan MPY. Okay, and then which one is higher? Make your conclusion. Which one is more productive? Okay, so that is for question number 22. Dapat yang ikut buku tu. Okay. Alright. So that will end our chapter 14.3. Okay, any question? Anything? Okay, if there is nothing, we have 10 more minutes. I will move on to 14.4. Okay, 14.4 is the maximum minimum. Maximum minimum is the test, okay? The test which make use of the second derivative, which we already learned last week, to determine whether the function has a maximum or minimum at a critical point. So that would be 14.4. So we are going to do the derivative test. All right, the derivative test in order to determine whether the function has a maximum or minimum. Okay. So, tengok 14.4. Okay, 14.4. I want you to look at the diagram. Okay, the figure 14.48. There are two figures, 14.48 A, 14.8 B. So now we are going to 14.4. We are doing the maximum minimum. Okay, so we're going to develop a test to determine whether the function has a maximum or minimum at a particular, okay, at a particular critical point. So that is a particular critical point. So in other words, the test is similar to what we have been doing. Okay, given a critical point, you want to test whether that point, that critical point, the function is maximum or minimum. Okay, all right. Now you look at the figure 14.8 A. Okay, that figure 14.8 A, the function, what does it tell you? Compared to B. When you do the comparison, then only you know what does it tell you, A and B. Okay, A itu apa benda? Cepatlah. A itu apa? Tell you what? Okay, Irfan. A, what does A tell you? Not just tell you. What does A tell us? Daniel. Daniel Nazir. A itu, diagram A itu. Tell you what? Whatever comes to your mind, just tell me. What? Nazir, are you here?
Maximum.
Maximum. Pandai pun. Okay. So that A give you maximum. B
Minimum.
minimum. Okay. Now you see there two functions. Two function is good. They give you one maximum and one minimum. All right. Now you look at the maximum point. You look at the minimum point. What do you see there? What do you see at the maximum and minimum point that is common to both situations? Beritahu je. Tell me, what do you see? Okay, cepat. Anybody? Okay, Umuhani. What do you see at the maximum minimum point though?
The shape is on the vertical axis.
The shape is on the vertical axis. Yeah, that's common, but not necessarily there. It can be anywhere. Okay, that's number one. But that is not that general. Okay, that can be anywhere. Okay, the maximum minimum can be anywhere on the graph. But here they just draw it on the vertical axis. Okay, paham? It may not be there. All right, but that's good. Okay, that's number one. Number two, apa lagi? What do you see?
The maximum graph is positive.
Turning point.
What? Maximum graph positive? No, I don't think so. Okay, what did you see? I just ask you, what do you see? You know what you don't see? What you see that is common. You know, the first observation that was good. You know, that was common because it's on the vertical axis. All right, but that may not be always the case. Okay, all right. What is the other one?
3D graph.
Apa dia?
3D.
PD? Apa PD?
3D, sir.
3D graph. 3D graph. Memanglah 3D graph because it's three variables. Okay? 3D graph. Okay, good. Apa lagi? Cepatlah. Ini jawapan.
Turning point.
That's a turning point. Okay? You see maximum and minimum. Both are what? Turning points. Okay? Turning point. Good. Critical point. Okay, because we're talking about critical point. So that's turning point. Now, at that turning point, what do you see? At the turning point, A, B, what do you see? At that turning point. Ini bukan gambar.
The maximum and minimum.
Yeah, I know maximum minimum. Okay, we already said that. But what do you see at that critical point? Ini bukan gambar. Ini bukan gambar tersembunyi. Ini gambar tu. Ini gambar apa? Gambar jelas dan jelas sejelas-jelasnya. What do you see at that maximum at the turning point in both diagrams?
So the second derivative test is more and is greater than 0 and less than 0.
Tanda. We don't say what you don't see. Okay. We just say what you see on the picture. What do you see? Nothing to do with the second derivative. The second derivative is the proper test, but just looking at the diagram. What do you see at the maximum point? First diagram. Minimum point, second diagram. In other words, at the critical point. Apa yang kita nampak yang common?
The orange region.
The orange plane. Nampak tak? You see the orange plane? Okay, that's the orange plane. We're getting closer. Now, in the orange plane, what do you see?
Cone shape.
Cone shape. Okay, dua-dua cone shape. Because one maximum, one minimum. Okay, that's already taken care of. Cone shape. Okay, apa lagi satu? On the orange ni, orange plane tu, apa you nampak? Dua-dua diagram ada.
The intersection z-axis.
That is what? Not the intersection. that is one, there are two lines. One line like this, one line like that. Do you see that line?
Yep.
A pun you nampak ada, dekat B pun ada. Okay. Now, what do those lines mean? So this is the one that is common. Okay. You will see at the maximum, you'll see also that thing. The two horizontal line, one going along the y-axis, the other going along the x-axis. And also that is true for the minimum, okay? The second diagram. And of course, that will be indicating the turning point. So these two lines are conditions for what? For turning point. Now, what is the horizontal line? Or what are the horizontal lines? What do they mean? Okay, the horizontal line, which is at the critical point, are the partial derivative. This is the partial derivative with respect to x. And this is the partial derivative with respect to y. Okay, now if you recall, when do the derivative is horizontal? What is the value of the derivative when the line is horizontal? When the slope is horizontal? When the line is horizontal, what does it tell you about the slope? Cepatlah. When the line is horizontal, okay, let's say you got y equal to f of x, f prime horizontal line. Yeah. So bila horizontal, apa slope equal? What about the slope? cepat. Kita nak balik ni. Nak balik pula. Nak habis kelas dah. Afiq,
Ya.
bila horizontal line tu apa? What can you say about the slope?
Oh, y equals to 0.
Zero lah. When horizontal line, the slope is 0. Is that right? So the critical point, okay, at the critical point, the partial derivative with respect to x, or in other words, the slope of the function with respect to x is equal to 0. And also, the partial derivative with respect to y, in other words, the slope of the function with respect to y is 0. So at the critical point, both of these must be true. Okay? So if you see that for a maximum, minimum, first thing that you need to do is you need to find the critical point. Now, what is the condition for the critical point? Fx equal to 0, Fy equal to 0. Okay, all right. So I think I will stop here. So we already looked up to the critical point, okay? And then after we determine the critical point, then we use the second derivative in order for us to show whether it is a maximum or it is a minimum. Okay, all right. So that's it for today. I will continue on Wednesday. So the Wednesday, we're going to do the 14.4. We do the proper test, right? The test is similar to the one that we are doing earlier, but with more conditions, okay, with a little bit more conditions, because here you have two independent variables. So the idea is similar, okay? The idea is similar. All right, so I'll see you again. Have a nice day. Practice, okay? I said to you earlier, practice the questions. And on Wednesday, we're going to continue. All right, okay, good. So have a nice day. Have a nice berbuka puasa. And I'll see you again on Wednesday. Assalamualaikum warahmatullahi taala wabarakatuh.
Thank you, sir.
Waalaikumsalam warahmatullahi
Salam. Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
sir.
Ron,
Okay,
sir.
thank you.
Thank you, sir.
All right, thank you.